Okay, so welcome back to another one of these videos where we create FA that accept languages. In this case, I want to design an NFA for the following language, L, where L is a set of strings that look like X, A, B, A, where X is any string of the alphabet A, B. So really, this is just a formal way of writing the language L as strings over the alphabet A, B, such that these strings end in ABA. Okay. So this is sort of just the more uh, formal way of representing the statement that's written in natural language in this case. Um, so I mean, I could design a DFA because a DFA is an NFA that just doesn't use non-determinism. But in this case, I want to force myself to use non-determinism. So in other words, I want to design a machine that uses a kind of guess and verify approach. So how am I going to use a guess and verify approach for recognizing strings that end in ABA? I need to kind of think where is the guessing and the verification occur if I'm reading a string, right? And I want to check if its last three symbols are ABA. Then what this guess and verify kind of algorithm is you can imagine some machine that's going through the string, and at some point it guesses. It guesses. So maybe here it makes a guess. It guesses that here it's three symbols away from the end of the string, right? So it guesses this, and then it also guesses that at this point, it's going to read the string ABA, right? So it guesses that it's three symbols away from the end, and the string that it's going to read is A, B, and then A, right? Then that's what it guesses, right? Then what the machine has to do once it sort of produces the guess is then it has to verify its guess. It has to check if the guess that it made was correct. Well, how do we implement a verification of this guess? We actually just add that transition, um, into the transition diagram, making the final state an accept state and not adding any transitions, right? Because then that tells you that the string, if I'm guessing that this is where the last three symbols are, then to check this guess, I'm going to have to actually read three symbols. So I'm going to actually have to, so if this is where I make the guess, then in my actual machine, when I make the guess, so here guess is made. So in this transition here, the guess is made. Then to check the guess, I have to first check that um, I was right about the next three symbols being ABA, right? So that's why I have a transition for ABA. And I also have to, so this is the verification that ABA is is the next part of the string. And remember the other guess, and part of this guess is also that this is the final part of the string. And so to do that verification, we make this the the last sort of state after which there are no transitions. So that um, if I'm here, if my machine reads ABA, if there actually was an ABA here, but there was more stuff, then my machine would jam, right? So at this point, if I'm at this state and I have no transitions, but I have more stuff to read, then that's a jam and that's a reject. So my verification fails. If instead I guessed here and I read ABA, then I wouldn't have any other strings to read. And so then that should be that the verification passes. So then I should also make this final state here an accept state. Okay? So this verification, this part of the machine verifies that ABA is actually the next part of the string. And this part of the machine verifies that ABA was the last thing, the last part of my string. If it actually was, right? So if my guess was correct in both cases, if my guess was firstly correct because I had ABA, then I would be able to get here. And if also secondly, I also guessed correctly that I was at the end of the string, then I wouldn't have anything to read. And I would say, well, my NFA has reached an accept state and it has nothing left to read, so it can accept the string, right? So that's, remember, acceptance for an NFA. How does an NFA accept a string? If it can find some walk through the state transition diagram, which consumes all of the string, and where the end of the walk occurs in a accept state. Okay. So now there's of course a missing part to this NFA is, the guess is made here, but I want to be able to make guesses every single time, basically. So I want to say, oh, I can make a guess here, 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 and then try all the possible guesses. And if any of them can be verified, then I accept. If none of them are verified, then I reject. So that tells me that I should also have the self loop here. So this self loop isn't really part of the guessing, right? The guessing and the verification is really just this part. This part of the machine is sort of just saying, I'm going to allow guesses all the time, at every single position, which is what an NFA does, right? It guesses every single time, and if it gets a guess correct, then it's happy and it accepts. Otherwise, it keeps trying, right? Um, and I'm going to make this the start state so that essentially as I'm reading the string, I'm at my start state. I'm essentially at the guessing state, and I'm at every single symbol that I read, I make guesses, I make the guess, and then I verify. If each of these fail, right? If each of these fail, then I reject my string. But if at some point one of them succeeds, then I accept my string. And so then this is the NFA that would accept this string, this language, which contains strings of this form.